Welcome everyone to Red Planet Live. I am your host, Ashton Zeth, and I'm elated to be hosting the Mars Studies podcast and leading the conversation about human exploration of the universe and the future settlement of Mars. As a longtime space enthusiast, I am passionate about STEM education and making humanity an interplanetary species. Thank you everyone for joining today and supporting Red Planet Live. Now, today's episode is a compilation of exciting interviews from the 2024 Mars Society International Convention. I had the opportunity to speak with incredible individuals, including retired Brigadier General Dr. Pete Worden, former director of NASA Ames Research Center, and Howard Hugh, the Orion Program Director for NASA, as well as many others. So you're going to hear those today. Stay tuned as we dive into the challenges and the triumphs of those that are working to make Mars the next home for humanity. Thank you. Well, with me today is Dr. Pete Worden, who is the chairman of the Breakthrough Prize Foundation, former director of NASA Ames Research Center, and a retired brigadier general for the Air Force. Thank you so much for being here.
Well, thank you for having me. I'm excited about being here in Seattle, and the Mars, Foundation is really a neat organization. So, as I think I mentioned during my talk, I visited, I was one of the keynote speakers about 5-6 years ago, so It's cool to see where the things have gone.
Yeah, I was going to ask you, how did you first get involved with Mars, with space? Where did your career first start, and how did you end up, partnering with the Mars Society?
Well, I'm an astronomer by background, and of course, my primary interest was and always is the nearby stars. I mean, I kind of consider our solar system boring. Obviously, it is a space guy, and I spent 29 years as an Air Force officer. But during one of those things, I was at the White House National Space Council during the first Bush administration. And that's when senior President Bush announced that we were going to, it was 20 years after Apollo, we announced we were going to go back to the moon and to Mars. So I was the staff officer, so I got very excited about Mars and what we could do there. And worked with NASA. Of course, I was a little skeptical because after working with NASA, because that NASA didn't want to do anything new unless they got lots more money. But got very interested in Mars. I met Bob Zubrin a long time ago and was really impressed with his bootstrap ideas that you could build fuel on Mars and so on. It's really the basis for a lot of the exciting work people like Elon Musk and others are doing today.
Well, speaking of today, as I mentioned, you're a chairman for the Breakthrough Foundation. Tell me about the organization, its purpose, and I heard you talking about in your presentation, there was the topic of searching for extraterrestrial intelligence. Tell us about that.
Well, the Breakthrough initiatives grew out of the Breakthrough Prize Foundation, which was started about 2010, is an effort to inspire young people to go into space and science by highlighting the contributions of great scientists, and also the idea that you don't have to be a movie star or sports hero to become rich and famous. You can do science.
Yeah.
So when I left NASA, I was hired to be the chairman of the Breakthrough Prize Foundation. But at the same time, the key founder, Yuri Milner, decided he wanted to do science, not just reward it. And his long-standing interest is, I think, one of the two big questions of science. The first one is the origin and structure of the universe. So minor big things.
Yeah.
And the other one is life. And we don't know what life is. Where is it? So on July 20th, 2015, we announced at the Royal Society in London, and it was hosted by Yuri Milner and Stephen Hawking, that we were mounting the breakthrough initiatives. There's about 3 or 4 pieces of it. The first piece was called Breakthrough Listen, and it was Mr. Milner committed $100 million for 10 years, and he's now expended another 5 years to really look for evidence of intelligent life elsewhere. The concept is that we might be able to find life in our own solar system or evidence of life in nearby star systems. But if it was a technological civilization, that it would probably do something. You could see it much further distances. So we've arranged for time on most of the world's large radio telescopes and some of the optical telescopes to look for a technosignature. And of course, most of it's in the radio,
right?
Because there's radio waves penetrate a little more easily than others.
Yeah.
Although we're also looking for laser signals. And We haven't found anything yet, but we had our first candidate a few years ago, which we called Breakthrough Listen Candidate 1, which was the very nearest star, Proxima Centauri. And we're now convinced that there's an interference. So we're looking at, can we put radio telescopes where they're not interfered with by terrestrial activity, and the far side of the moon being one of them.
Okay.
The second major program was Breakthrough Starshot, which was the effort, can we send probes later this century interstellar distances? Now, to get there in reasonable amounts of time, you have to go 20% light speed. There are ways to do that with a laser-driven light sail. So we put a fair bit of effort into looking and seeing are the problems solvable. The answer is yes, but it's probably not quite affordable yet or near term. So we're transitioning that program to more university research. It'll be run out of Caltech.
Okay.
And the third program is Breakthrough Watch, which is the idea, can we find any life elsewhere? And so we had two parts of the program. One was, where would we go in our solar system to look? Now, we felt that NASA and other space agencies had Mars covered, but maybe they don't. So we looked at things like Europa and Enceladus, but we also looked at Venus.
Yeah, the clouds of Venus?
And we funded some efforts by Professor Sarah Siegert.
Okay.
And out of that grew a mission now that Rocket Lab is funding to go and drop a probe in the upper atmosphere of Venus. Hopefully goes next year. And it's the instrument itself is now being funded by a sister foundation, the Schmidt Sciences.
Okay.
So the other one is to see if we can find a life-bearing exoplanet. And of course, we haven't found Earth 2 yet, but I think we're close. And so we have 3 or 4 programs, including space programs, others using large ground-based telescopes, ultimately looking at big space telescopes that could be privately funded or partially privately funded. So I'm convinced that there's kind of a race. Are we going to find life in our solar system before we find evidence of life in nearby solar systems?
Yeah.
And we also have an annual conference called Breakthrough Discuss, which we moved that from California to the UK. This year was the first one we held at Oxford University.
Very exciting.
Next year we're going to hold at the same place. What was kind of neat, we held our primary reception in the Bodleian Library, which it's a 15th century, 16th century building that you people probably saw because it was the hospital in Harry Potter's.
Oh, okay.
It had all this sort of ambiance of old medieval stuff. So, but at any rate, those are our major programs.
Okay, I see articles and headlines all the time. Earth-like exoplanet. It's very similar. It's got water. It's got this. It's got that. Which of those would you say is the most like Earth right now, and maybe has the best likelihood or probability that there could be life there?
Well, the problem is when astronomers discover something, they always exaggerate a little bit, as I do.
A little overzealous about it.
And the headline is, and I think it's the university or research institute PR people say, Earth-like planet found. Well, no. As of yet, there's been nothing that's really is sort of Earth 2. We haven't even discovered an Earth 2 sized planet. It's very hard to do. Yeah. There's evidence of some indirect evidence that you can see by wobbles of stars that there's probably an Earth-like planet there. Most of the Earth-sized planets have been discovered orbiting red dwarf stars, which are they're very close to the star. There's an argument of whether they're even possible to have life there. Some of the follow-ups that's been done with the James Webb says this doesn't look very promising. It looks like it's a bare rock. But we have only looked at a handful. The other thing that's been done is found sort of super Earths, things that are somewhere between the size of Earth and Neptune. Those are interesting, but they're not Earths. Some of them may show evidence of a chemical that's called non-equilibrium, meaning it probably created by life, or could be. But that's a real arguable point. I mean, you're right at that hairy edge of detectability. So I'd say that not just the jury is out, but there's not even much testimony yet about whether there's one. But I think in the next decade there will be. Yeah.
That's what everybody's hoping for.
Right.
In the next decade. That's what we keep saying. Well, I wanted to ask you about your time as the director of NASA Ames. I'm curious, what were some of the most rewarding parts or missions, maybe projects that you oversaw, and what was the most challenging?
Well, the neatest thing at Ames was, I'm an astronomer, and my true love is the nearby stars and finding planets. So without a doubt, to me, the most exciting mission was Kepler, which, and it was a real challenge. I mean, we had cost overruns and there was threats to cancel it. But when it launched,
like every
mission, it actually, showed that essentially every star in the galaxy has a planetary system. When I went to graduate school way back last century, people didn't believe most stars had planets. They said only some very special cases. And now we find essentially every star has a planetary system. And it looks like statistically about a quarter of them probably have an Earth-sized planet, in sort of a habitable zone. So that was really cool mission. It had its challenges. The reaction wheels, the control, the orientation. One of them failed right away, and we fortunately had an extra one. And then the other one failed about 4 years later. It actually failed one day after the 4-year point, which was the design goal was 4 years. So I said, well, at least we met our design goal.
We got there.
But then they figured out how to stabilize the third dimension using solar radiation pressure. But that was a cool mission. The other one is we did 2 missions to the moon. I didn't have a strong interest in the moon, although I've now been involved as a lead role in 3 missions. The first one I did in the Defense Department was Clementine.
Okay.
That was the first mission back to the moon the U.S. did in 20 years. The other 2 missions we did at Ames. The first one was L-Cross, which the Clementine mission was the initial tentative detection of ice in the lunar poles. The L-Cross mission proved it, by actually ramming a spacecraft into the. Now, I made a mistake when we launched it of saying that this was the first precision bombing run on the moon, and it was a bad idea because people said, "Well, he's an Air Force general. Obviously, there's some aliens we're going after." I got consoled over that one. But then we did another one, the Laddie mission, which was looked for the residual lunar atmosphere, which is an important question. So we did all those missions. Of course, there was a lot of Mars activity at Ames, a lot of the science missions. To me, one of the personally most exciting is I worked with Chris McKay and others. Ames was the head of astrobiology, and I think the thing you come away with is that we don't know much about life, and the range of where life can be and what it can be is so wide, and it's very exciting.
Yeah.
The other thing is we started the synthetic biology effort. It was the effort, can you actually tailor biology? And why I think this is important, if you talk about settling another world or living there, that if you say, what do you really want? Well, you'd like to have what's called a von Neumann machine, which is a self-replicating programmable machine that does things for you.
Okay.
And people pointed out to me, said, well, we have that. That's called life. And we're at the verge of being able to program it. So I got very excited to say that rather than go to Mars with some manufacturing to build all these little robots, let's go to Mars with a toolkit to do synthetic biology where you can tailor things that can operate in those environments, that can produce what you want. So rather than building a habitat, you grow it. And so I think that those were all stuff we did at Ames were very exciting. The downside of Ames or any other government agency is it's government. And there was nobody that could say yes, but there were hundreds of thousands of people could say no.
Yeah.
And so it was hard to do something new. And one of my big challenges is that I was kind of a change agent. And some people liked that, but there were some on my staff and I knew who they were, that hated it and didn't like what I was doing. And now if I was in a private corporation, bluntly, they'd have been fired. But in the government, you can't do that. So, the good news is you can't be capricious like you could in a company, but the bad news is sometimes you need to be, move quickly. So those were the challenges. I mean, there were people that tried to claim I was running a Chinese spy ring, so some rubbish like that. Well, the government investigative agencies take those things seriously. So the last couple of years I was there, I don't know, the FBI is going to be at my door and ask me about some ridiculous, I found out one of the claims that I had a Chinese spy ring is I had somebody with a Chinese surname in my mission design center who was a Spanish citizen. He wasn't, his grandparents had come from China or something. And so this was the claim that I had this Chinese person. And I got really angry. I said, this is just rubbish. I mean, this is racist. And, somebody's surname is Chinese. I mean, he was born and raised in Spain, a U.S. ally. He's now a U.S. citizen. So, I mean, these are the kind of things that are, and he had all the accesses and everything. So so that was the challenge. That was the downside.
I did not imagine that you were going to say that.
Yeah.
That was totally unexpected. But it makes sense that, like you're saying, with government agencies, there's a lot less of people to say yes and a lot more to say no, and that's why private industry and commercial companies are seeing such rapid growth right now in the industry. Obviously, SpaceX, but also, there's many others. We all know Blue Origin, Axiom. Anyways, small companies.
Right.
Corporations, they're seeing a lot of rapid growth, and that's what we're seeing on the horizon. Is that something
Rocket Labs.
Rocket Labs. That I knew it was an R.
Yeah.
Is that what you're excited about as we look forward into the next decade and what's coming?
Well, I think the thing is that I have a love-hate relationship with NASA, and I think NASA has really changed.
Yeah.
It's not your grandfather's NASA or my NASA that I grew up in. It's things like the Commercial Lunar Payload Services Program are using, Blue Origin, SpaceX, and other new companies, and Rocket Lab for that matter, is a real change that they don't have to do the stuff themselves, that they can actually focus on the science and exploration rather than the engineering of building the logistics. And I think that's an important, just like the U.S. Air Force doesn't build its own airplanes. It buys them from companies.
Right, contracting.
And I think NASA's now doing the same thing. So it's a big change. And it also the new factor, sort of as my own foundation is that traditionally in the United States, high net worth people, as they got older, felt they had a responsibility to do, to fund things, and among other things, it is science.
Yeah.
And we're seeing that again. We're seeing that for the first time, private funding of space missions, and that's exciting.
Yeah.
I mean, in one hand, they may do things that people think is questionable or scientifically dubious. On the other hand, that's how progress is made. I mentioned the looking for life in the Venusian atmosphere.
Yeah.
When we first, sort of raised that, everybody. But now there's increasing evidence, and I think ultimately there'll be government missions. But this is where the private sector can be the real pioneers.
Yeah, absolutely. Everybody starts as a skeptic, but as soon as you see that data come back and, this is promising, you get a lot more supporters. Right. Well, Dr. Pete Worden, thank you so much. I appreciate your time.
Thank you for
speaking
having
with me. Excited to speak with you.
Thank you.
And with me is Bryan Versteeg, who is a conceptual designer. You just gave a presentation, and I'm a little biased because we're talking right now, but I have to say it was one of my favorite presentations so far at the convention. So for those that are listening, can you give us a quick recap of your presentation today?
Sure, thank you. So I talked about I'm a conceptual designer for the space exploration industry. I create images that help to convey topics and difficult to understand concepts about space exploration and the human settlement of the solar system. So topics like asteroid mining and in-orbit refueling and construction, and what places could actually look like that people are going to be living in off of this planet. My topic, my conversation was very much about the simulator that I'm building, which I hope to be something that will bridge the conversation or bridge the gap between people who aren't necessarily in-depth understanding of the space exploration industry and the current technologies and issues involved in human habitability of other planets. And so the game itself is going to be, it'll show topics about agriculture and research and exploration and supporting of life support systems and energy management, resource management, and logistics and that sort of thing.
It definitely had a feel of like Sims. It reminded me of like planning a city, and you've only got so much, resources, and so I really liked that. Where and when will we be able to access this game?
I'm hoping that the early beta will be available in early 2025.
Okay.
But inevitably, it seems like it's 5 months away, no matter how long I work on it.
Early 2025 is when this will be available. I'm curious. So when a lot of people think about the space industry, they imagine astronauts who are that traditional, like military test pilot. They're scientists, they're engineers, and we're getting into the new age of space, and it's becoming more accessible with the private and commercial industries. And I'm curious to hear your opinion on where do artists fall into the overall industry? Because it's not just engineers and it's not just scientists, but where's there a place for artists?
Well, I think there's a huge place for artists. I grew up in many different kind of isolated parts of Canada where I had no one around me who had even access to the space industry. So I never could have imagined that I would be involved in space programs. So I started creating images. I've always been an artist and a designer. And so I, almost as a hobby, I just started designing things that I thought would be interesting to see on other planets or asteroids, or it was really just a curiosity for me. I loved this, an act of exploration where if there's a lot of things we haven't seen, and there's a lot of things that are theoretical, but if I could design something that is theoretical and I'm the first one to see it, in a way I've just explored something. And so for me, when I create these scenes, it's an act of exploration. So I am exploring these habitats that don't exist yet and may never on other planets. Because of the timeline of space exploration, there's a lot of things that we're not necessarily going to be alive to see. And so if I want to see it in my lifetime, I kind of have to create the image myself. So I'm really just trying to see a lot of things before I die. And that includes what it looks like to live on other planets or in large stations and in orbit. And so I'm just kind of trying to fulfill these childhood dreams of what would it look like, and if someone else hasn't already created that image, then I feel like I have to.
I liked what you said in your presentation, that a picture is worth 1,000 words, and then you showed a video and you said this video is worth 1,000 images. What does that mean for trying to paint an idea or create a visualization that people can understand, and it opens their understanding of what could be out there?
Well, when I share an image, and I try to share as many images as I can. I try to get them to a point where they're ready for other people to see, because I want other people to understand the vision or share in the excitement of what could be. And when they see an image of something that doesn't exist, or something that perhaps they've only thought of, or something they haven't thought of, then it really occupies a part of their brain that is now enabled to think about this one particular topic. They now have an image to go with. It's kind of like putting a face to a name.
Right.
And as soon as you meet that person, all of a sudden, whenever you hear that person's name in the future, you have an understanding of what they talk like and what they look like. And it's when you have this image in your head, then you can kind of move the entire conversation forward. And when you have an animation, then you have a better understanding of the space that we're talking about and how that space might be used. And what my intention is with this simulator, it's kind of a game/simulator, is that I want to be able to take the viewer and immerse them into the space. Where I've always been limited in the past by showing people a 2D image of something, and that's kind of limiting. You want to be able to reach into it and actually interact with it and walk around it. And so in something that's a simulator, I want the viewer, whether it be a 9-year-old grade 4 student, or a college student, or someone who's many decades past that, who just wants to play around, walk around the surface of another planet in a game and interact with the different elements involved in what we would experience there. That going into the farm and planting your basil and your rice, and going out and dusting the solar panels, and walking over dunes and picking up rocks to see what's on the other side of them, and exploring lava tubes, and just the experience of being in an otherworldly habitat has always been fascinating to me, and I want to be able to share that with as many people as possible.
I love that. Well, speaking of images, we have a couple, and hopefully you can walk us through what we're looking at here.
So this here is, I like designing large structures, places where you're not really confined to. A lot of people, when they think about space stations will think almost in a claustrophobic type scale,
Sure.
where it's you're limited in space. I like to show larger spaces. This is an example of in orbit manufacturing, places where I could see friends and family who aren't as interested in living off this planet as I am, and so perhaps their tolerance isn't as wide as mine, and so they want larger spaces, better quality of life. But I enjoy showing the infrastructure involved in just how we get these places. So how we'd make it in orbit, but inside a place like this would look.
I really like this one.
Hopefully something like this. So again, when we're talking about quality of life, I would want to bring the things with me that I enjoy here on Earth. And so I like going on hikes. I like walking in the trees and forests. I like gardening. I like nature and ponds and rivers and creeks and so I would want to bring that all with me. And so when someone talks about perhaps living in a space station, oftentimes they would have a negative opinion about whether or not they would see themselves doing that.
Right.
And it's often predicated on something like not enough space, or they've seen dystopic future space stations, or it's extremely just like white and sterile.
Yep.
And I'm hoping that it could be a lot more natural, a place that a lot of people would want to live.
A little more homey, something that they're familiar with.
Exactly.
And the green and the lush life, I mean, that doesn't make you feel like, oh, I'm floating out in space, but I'm back on Earth, something I'm comfortable with, and that there's growth, there's life here. That's why I particularly like this picture.
Yeah, if you take a snippet of it here and just zoom in, it could look like any neighborhood that people would love to live in.
Yeah.
And in context, you understand that this is a large cylinder that is rotating, but without that context, ideally on a micro scale and a neighborhood level, it should have all the things that the average neighborhood should have. Parks and a playground for the kids,
Yeah.
and a little corner store and places to get your bread and fresh veggies and.
Yep.
I'm a big, as a gardener, I like having things in my garden that I can eat, and so berry bushes and herbs, and so the potential for someone to do their own gardening here and basically eat while you garden and get your own fresh herbs and veggies from your own garden even. Not just to support and supplement life support systems, but to support and supplement mental health. Gardening is therapeutic. And getting your hands dirty is therapeutic. And so I think opportunities like that, the things that people really enjoy here on Earth, as much as possible, bring those with us, have big enough spaces that we can bring those with us, because it's not just about whether or not we could live off the Earth, but whether you would want to live off the Earth.
Right. Okay. Well, this is really exciting. I think the visualization really makes it digestible for people about the concept of living out in space. I have to ask, what are you most excited about? I mean, you've worked with the various different companies to create images like this. Do you have any projects coming up that you're looking forward to that you can tell us about?
Well, I'm hoping the simulator is. I'm hoping to be able to offer modules of the simulator that people can play individually, and I hope that they are useful for anything from grade school science teachers to just enthusiasts to be able to play around with different elements and aspects of human habitats. In the industry itself, I'm really excited about watching things like the SpaceX Starship continue to progress. I think that really changes the equation in so many different potential missions and opportunities and potential. And I think it's a very interesting time right now in so many industries that have direct influence over just human potential and capabilities. That it's an interesting time right now. The next couple of years are going to be pretty fascinating.
Absolutely, I 100% agree with you. Very exciting time in history, as we're watching, the next phase of the space, the golden age. We've had that, but now we're in the next phase, and I'm really excited about that. So thank you so much, Bryan, for chatting with me.
Thank you for having me. Thank you.
With me is Professor Edwin Kite. Thank you so much for being here and chatting with me. He's a prominent researcher at the University of Chicago who is developing a novel technique for terraforming Mars. Can you give the people a quick recap of your presentation?
This is early stage research. At the moment, we're only using computer models. We would like to start batch manufacture and small scale testing, but for now, that's in the future. The question we asked is if we wanted to warm Mars up in the future, could we do it with engineered aerosol? This was a team effort. My group collaborated with Huma Masseni's group at Northwestern University and Ramses Ramirez at the University of Central Florida. And our first paper, which was published open access in Science Advances, is led by Samena Ansari. She's a graduate student in Huma Masseni's group at Northwestern. In the paper, we simulate what would happen to Mars's surface temperature if engineered aerosol, so small conductive particles about 9 microns in length, were released into the atmosphere. Similar to the natural dust of Mars, they'd be swept to high altitude and blown around globally. And what we found is that the warming from these aerosols would be about 5,000 times more effective on a warming per unit mass in the atmosphere basis than warming from the best combination of artificial greenhouse gases. So the next steps are to continue to improve the particle design, small-scale batch manufacture and testing of the particles, alongside improved climate modeling and also weather modeling of what happens very close to the release point or points. To keep Mars warm, you would need to continue to make and release these particles. If you stop releasing them, Mars would revert to its current cold state within a few years, perhaps a decade.
Okay, so from your presentation, what I understand is that you're essentially taking, I believe it was iron and aluminum nanorods, and you're essentially creating a greenhouse effect. What would be the impact of that? I think I heard something about revealing potential lakes and rivers.
So warming Mars is a necessary step to making Mars's surface habitable again, but it's not sufficient. From the point of view of a microbe, Mars's surface has many stresses, and it would still have many stresses even if Mars was warmed up. Mm-hmm. In particular, the ultraviolet light is very strong compared to Earth. The soil is very salty and has perchlorates. Now, each of these challenges are met by some Earth microbes. For example, on Earth, there are perchlorate-reducing bacteria that make a living by converting perchlorate to molecular oxygen. Mm-hmm. But a pioneer microorganism would have to deal with all of those challenges at the same time, and that might require synthetic biology. Making liquid water at or near the surface of Mars is a necessary step for making Mars's surface suitable for photosynthetic life, but it's not sufficient.
Okay, all right. And talk to us about what is the implication about finding life. We're obviously talking about Mars, and the goal of the Mars Society is to get humans to Mars, to colonize Mars. Talk to us about the implication of this research. So you're trying to warm up the surface of Mars to make it more habitable. What does that mean for us?
Crops.
Simply put, crops.
10 to the 16 watts of sunlight falls on Mars's surface area, and none of it right now is used by life. Mm-hmm. That's the same to within a factor of 2 of the amount of sunlight that falls on Earth's land area. And on Earth, that 10 to the 16 watts powers almost everything of value to us.
Mm-hmm. What are you optimistic about? We've been talking with other presenters and saying, what are you most excited about? This is a conference to talk about research, to talk about the efforts that are being made by the scientific community. So what are you most excited about with the research that's coming out right now?
Oh, we're in the golden age of Mars exploration. We're encountering all kinds of scientific questions that we don't have good answers to. So just today in the conference so far, speakers have brought up elemental sulfur deposits that were found by Curiosity, mm-hmm. and the reduction, or what looks like reduction spots or leopard spots that were found by Perseverance. It's great fun to be able to think about these puzzles that wouldn't be possible without rovers exploring the surface of Mars.
gives us a lot to be excited about. The like you said, golden age, the final frontier. We're excited to see the news and the developments that come about with getting humans to Mars. So thank you so much, Edwin.
Yep.
It was a pleasure chatting with you.
Thank you.
Thanks, everybody. Well, hello, everyone. With me today is Anna Wadhwa. Thank you so much for chatting with me.
Excited to be here.
I had an opportunity to watch your presentation, was very excited. Anna is an MD student at Harvard Medical School and a PhD candidate at MIT's Aero-Astro department. So excited to chat with you. Had a chance to listen to a little bit of your presentation. Give us a recap or a summary of your talk for those that were not able to attend.
So I mostly talked about the MHU-8 mission, which was a collaborative mission between NASA and the Japanese Aerospace Exploration Agency, or JAXA, to look at the effects of artificial gravity. Specifically, we were centrifuging or spinning a lot of mice in chambers in space or on the International Space Station. And if we spin them at different speeds, they'll experience different levels of artificial gravity. And so we were looking at the bone effects, the muscle effects, and the locomotor or gait effects on how that artificial gravity affects the mice. And what we found, the bone team, we found that we really need 1G of artificial gravity to prevent bone loss in space. A lower amount of artificial gravity just wasn't going to cut it, unfortunately. But interestingly, the muscle team found that a good threshold for preventing muscle or gait changes would be 0.67G. So they actually did not need 1G to prevent losses in, for example, grip strength or certain gait performance measures, which was really fascinating. But overall, in terms of what that means for human spaceflight, I think we need to be weighing, bone risk versus muscle risk versus gait risk against each other. And I think it becomes this conversation of what is an acceptable risk, what is an acceptable deficit, and who's going to make those decisions about that. I don't think there's an easy answer for that, unfortunately.
Yeah, it's a tough one to answer. Talk us through why this is crucial or impactful to sending humans out into the universe for space exploration and future missions to Mars, perhaps.
Absolutely. I think artificial gravity, especially by centrifugation, is so important for long-duration human space travel. And I think that's because, especially for bone loss in space, we don't see any plateau in bone loss. And that, the longer astronauts are in space, the more bone loss they experience. And eventually, if they go to Mars, for example, or they go somewhere else for, let's say, an asteroid mining expedition, they're going to be experiencing gravity again. And weak bones can't take gravity. They're going to end up with bone fractures. They're going to end up with performance deficits. And so I think if we can prevent that bone loss during the travel period of it, for example, with artificial gravity, we might not have to experience those kind of performance deficits once we get to our destination. So kind of preventing problems before they occur.
Understood. Okay. Well, I have to know. I mean, like I mentioned when I introduced you, you're a medical student at Harvard and you're a PhD candidate at MIT. How do you find the time for both? How did you get on this path? Could you not decide between I want to be a doctor and a potential astronaut and I'm just going to do both? Like, how did you end up in this role now?
That's such a great question. I get asked it a lot because it's so much to juggle. When I was in undergrad, I was primarily on the pre-medicine track, so I wanted to be a doctor. That was first and foremost in my head. And I was just trying to find different specialties that I was interested in. So I was shadowing different physicians here and there. There was one doctor I met, Dr. Dana Levin. He's now, I think, CMO or a flight surgeon at VAST, actually. But I was shadowing him in emergency medicine, and he turned to me and he goes, "Do you want to know about the work I do for NASA?" And I was like, come on, man, an emergency medicine doctor doing work at NASA? No way, tell me more. And he started explaining the work he does for Exploration Medical Capability, or XMC, basically doing a volume versus benefit analysis of different medical equipment for what would be the most impactful or most useful for us to send to space. And I'm sitting there and I'm thinking, for the first time in my life, I'm thinking, how do I get your job in 20 years? I could physically feel something shift inside of me, and I was like, this is it, I found my calling. And so I completely pivoted. I, decided to take a gap year. I worked at I'd had a couple different NASA internships, exploring different areas in space medicine. I knew I wanted to find a way to marry the two of them. And so that's where the MD PhD comes in from, medical school to really understand how to help the human body, how to make sure we're safe both here and in space. And then the PhD to really take a deep dive into research and understand not just human health today, but human health for the future and what that might look like for the human race. You know, if we start thinking about space travel in a long duration type of sense.
That's so exciting. That's incredible. Like, I have to commend you. I mean, it's hard enough doing one program, but to do two and to try to find a path that blends the interest, that's incredible. I commend you for that.
I appreciate that.
Well, we do have a good track record, I just have to say, of guests we've had on Red Planet Live. We've had two women, including Emily Calandrelli and Dr. Shauna Pandya, who have both been on RPL and since announced that they are going to become astronauts in space.
Oh my gosh, that's exciting. So maybe third time's the charm.
Exactly. Well, what's next for you? I mean, what are you most optimistic about? Like, what's on your roadmap for the future?
Yeah, so for me personally, I just finished up 2 years of medical school. And since I'm in this MD PhD program, I now shift gears and I start grad school. So I'm going to be at MIT's Aero-Astro department. But long term, I'm really interested, you know, apart from the lofty goal of being a physician astronaut, which is a long shot by any means, though maybe if commercial spaceflight, you know, really takes off, that won't be a long shot anymore, which would be really exciting. But I think I'd really love to be somewhere at the intersection of medicine and space, whether that's, you know, for example, being CMO at some spaceflight company, thinking about how we can advance human space travel safely. I really want to be someone who's thinking about how can we get to places we've never been before, but how can we get there safely? How can we get there faster? I think all of those questions are really important, and I think being an MD PhD student hopefully will give me the skills I need in order to be that person.
That's so exciting. I'm so impressed, and it's such a pleasure to chat with you. And I'm really excited to watch as you're on this path and where you go next.
Thank you.
It's been a pleasure chatting with you.
Absolutely, likewise.
Thank you so much. Well, stay tuned. We've got more interviews coming. Well, with me today is Dr. David Caitling, who is a professor of Earth and Space Sciences at the University of Washington. Thank you so much for being here today.
Happy to be here.
Excited to chat with you. So please tell us about your presentation that you just gave here at the convention. You're talking about co-evolution of planetary atmospheres and potentially search for life on Mars. Talk to us about that.
Right. So my interest is in planets and whether they were habitable and had life. So my research focuses a lot about how it is that Earth is very different from our neighbors, Mars and Venus, and then thinking also about planets around other stars, exoplanets, and what kind of planets are they like. And so I just gave a presentation about how Mars got to its present state. So today Mars is dry, it's cold, it's a sort of desert planet. But I explained how in the past there are all these signs of liquid water, that Mars was a fluvial planet, meaning that there was a flow of rivers and streams, and we can see evidence for that. And so basically I talked about what we know about volatiles. These are substances that at the prevailing temperatures of a planet can turn into gases and vapors and liquids. And so, for example, carbon dioxide, where is it on Mars? How much is there in the caps or in the subsurface or locked up into minerals? Or water, how much is in the caps? How much is in subsurface ice today? And then thinking about what it may have been like in the past and how there must have been a thicker atmosphere and at least temporarily to support the flow of liquid water on the surface, because today it's so cold that everything's frozen. And what happened to that? Where did it go? What changed? How did Mars end up like it is? So that was sort of where I started in the talk, and then I talked also about whether there's life on Mars and the signs of life that we're sort of looking at with somewhat indirect data at the moment, because we don't have a full university department on Mars, so there's just the limited instruments that we have on something like the different rovers.
Okay, and talk to me about your research. I know you were previously with NASA and you were part of the Phoenix mission, which was researching Mars's northern polar region. Tell us about that research, and were there any interesting findings?
Yeah, so I mean, Phoenix was very different to the mission that I'm part of now, which is Perseverance rover, because it was a much smaller science team.
Yeah.
Like 35 people on the science team versus 10 times more on Perseverance rover, and so it was a fun experience to be just in the room because everybody fit in a room, right? with all those people while the mission was happening. It was a very different mission because it was a lander. It wasn't mobile like a rover. And it also went to about 68 degrees north on Mars. That's sort of the equivalent of the Arctic of Mars. And the purpose there was to dig at least part of it was to dig in the subsurface and see what was revealed. There had been inferences from orbit that there was sort of a permanent ground ice, so subsurface ice in the northern latitudes of Mars and also in the southern hemisphere, high latitudes, but we landed in the north. Was that expressed at the local scale? If we dug up, would we find this ice? And one of the other things that Phoenix did that I was involved in was that previous missions had never done something as simple as taking soil, adding it to water, measuring the pH and what dissolved, right? So there was a wet chemistry experiment, kind of thing like you might do in a chemical lab on Phoenix, and that did have a surprising discovery because we were expecting that we might find salts like on the Earth, where there's a lot of sodium chloride, the stuff that we put on our food, and that's mostly what's makes the sea salty. But we found that the chlorine was actually in this very oxidized state called perchlorate, which on the Earth is used to make fireworks and rocket fuel. You add it to gunpowder and you set light to it, and it makes a nice firework. But the atmosphere of Mars, we think, had made this very oxidized chlorine, and that also informed us about results from way before the Viking lander results, where they'd taken the soil and they'd heated it up. And when you do that with perchlorate, the perchlorate will react with organic material and make carbon dioxide. It's a bit like a controlled firework, if you like. And so that allowed those earlier results about lack of organics from Viking to be reinterpreted, and people thought, oh, well, your protocol, the way that your experiment worked, destroyed the organics, so you didn't find any. And so that actually motivated this idea that maybe, that there is more widespread presence of organics on Mars. It's just that there's this weird substance in the soil, quite a high percentage. It's 0.5 weight percent. It may not sound like a lot, but that's a lot for one type of salt in a soil. And it also has implications for human exploration because you don't want to eat it. So if you perchlorate has about the same size as iodine when it dissolves as an ion. And so it gets into the thyroid and it disrupts one of your hormones, thyroxine, the growth hormone. And so when animals have this, all sorts of weird things happen to them, like fish will change sex. And you don't want that happening if you don't, or various other hormonal effects. So anyway, so if humans go to Mars, they're going to have to deal with that. If they want to use the soil, they're going to have to kind of get rid of that perchlorate in processing, and actually we know something about how to do that because there are a few soils on the Earth, like in the Atacama Desert, where this is also a problem, the perchlorate. So people have thought about how to do this. So anyway, that was a sort of chemical discovery that people weren't expecting, and also people hadn't, because they hadn't expected, they hadn't sort of extrapolated to how that was going to influence our reinterpretation of Viking results and things like human exploration and so on. So it's kind of fun to be involved in something like that, where you find something unexpected and new that has broad implications.
Yeah, that was actually going to be my next question. What are you most excited or optimistic about? I see articles like NASA just published something about finding sulfur deposits on Mars. So let's leave the people with something exciting. What are you optimistic about in the search for life on Mars?
Well, I mean, whenever you send something to Mars, you always find something new, right, that you didn't know before. Like, for example, the thing you just mentioned, that's Curiosity rover, where it is right now, there's lots of sulfur, elemental sulfur, yellow sulfur. And when there's clasts of it, so lumps of it, and what was advertised in the news is where the rover actually drove over one of these clasts and broke it up, and you could see the yellow sulfur. And that's really interesting because where did that come from? And I bet if we were able to analyze it in detail, which unfortunately we're not with that rover, but it would probably show that the sulfur originally came out of volcanoes and maybe went through the atmosphere, and maybe it's a sign that once the atmosphere was free of oxygen, unlike today, and more like the atmosphere that we think is conducive to an origin of life. So it has important implications. And that's what I'm excited about, these new discoveries that perhaps have global implications. And the same with the recent discovery of Perseverance rover with a rock that I mentioned in the talk, where it's found what could be potential biosignature, and that's been sampled, put in a tube, and could come back to Earth in the future and provide a lot of interesting data to analyze for scientists down the line. So that's what I'm excited about. And also things that we just don't know. We might find them next week. Who knows?
Yeah, the unknown is definitely exciting. Well, I appreciate your time. Thank you for speaking with me today. It was a pleasure meeting with you, and we'll see you on the next one.
Okay, my pleasure. Thanks.
Thank you.
Well, with me today is Howard Hugh, the program director for Orion at NASA. Thank you so much for chatting with me today. You had an excellent presentation. I was just telling you, I love those videos that NASA puts together. They're so inspirational, gets people fired up. But talk us through what the Orion program is focused on right now. What's its purpose, maybe some of its goals, objective of its mission?
Well, the Orion program is responsible for the spaceship that takes humans to the lunar orbit. And certainly we're very focused on, we had Artemis 1, a very successful mission, late 2022, where we were able to test out a lot of the systems for the spaceship. And now for Artemis 2, we'll send a crew, and we're going to test out the crew systems. So life support systems, the ability to fly the spaceship using displays, and responding to anything that happens on the spaceship. And being able to operate the spaceship in a manner, kind of like a test drive for your car, so you get an opportunity to do that. And so that's our primary focus right now. And of course, another focus I would say is getting the next mission ready, Artemis 3, which is trying to land people on the moon. Now, Orion will not be landing on the moon. Orion will be taking the people, and we'll meet up with a human landing system that will take people down to the surface of the moon and back. And then, of course, Orion will bring them back from the lunar orbit.
Okay, very exciting. What's the latest, if you can tell us, on the selection for the crew? So obviously we know for Artemis 3, we've got a handful in there. We've got Christina Koch, we've got Victor Glover. But with the Artemis missions and getting humans back on the surface of the moon, we've heard that there's going to be the first woman, first person of color. I'm sure you can't tell us who that is yet, but what is the selection like? Do you know?
I'm not involved in the selection, fortunately. I think it's a really tough selection.
Yeah.
Like you said, on Artemis 2, we have already 4 crew members, terrific individuals and awesome astronauts. They were selected last April. So usually about a couple years out, you want to start selecting the astronauts, to start figuring out their training schedule and get them focused on that. And so I don't know what the timeline looks like, so I can't answer that question. But certainly we're going to select the right individuals who are going to be the first walkers on the moon again.
That's very exciting. We're all anxiously waiting for updates on that. So talk to us more about Orion. So we obviously know that throughout the years, you've been involved in lots of different missions. I mentioned in your bio, International Space Station and the Space Shuttle. What makes you excited about Orion versus the other programs that you've been a part of?
Well, I would say that, what got me inspired as a kid and why I went to work for NASA was deep space exploration with people. I wanted to be part of something that went to the moon and to Mars. And in the back half of my career, I've been able to do that. I think the stepping stones on International Space Station and Space Shuttle was really important for us to learn in low Earth orbit. We've had continuous operations for over 24 years on the International Space Station. Partnerships that we were working with the Europeans, the Canadians, really important to demonstrate that partnership, but also collaborating, working together operationally, real time, where people's lives depend on it, was really good. And now we're going to go several days beyond. So we got hours on low Earth orbit. Now we got several days. And I think learning how to operate in that environment where you have that much distance is really awesome. And of course, for me personally, that's what I came to NASA to do, and I get a chance to at least build the spaceship that's going to take people to the moon.
Well, you mentioned a word that we all love, Mars, and this is the Mars Society's conference.
Yes.
Talk to us about where Orion sits in the progress of getting humans to Mars.
Yeah, I think we're making great progress. I showed just earlier a picture of the integrated spaceship, so the crew module, the surface module stacked together. We've done a lot of integrated testing, very successful. We're in the final throes of getting the vehicle going forward. So we're at the cusp. We're trying to target September 2025 to launch Artemis 2 as a flight test with crew. And then we want to go right after to try to get a lunar landing mission. On Artemis 3. So really important, we're building spaceships. That's my main focus. How we utilize the spaceships will be dependent upon the missions that the agency determines. But my job is to get as many spaceships built and ready to go, and kind of get assembly line and get them ready so that people, whoever the crews are going to be, will get a chance to fly them.
We're so excited about that. And you said your job is to build spaceships.
Yeah.
What are some of the challenges that you're facing right now to build those spaceships?
Yeah, it's a very complex machine, and that machine requires thousands of individuals to do precision work. So we're going to discover some mistakes. We're trying to recover from some things we found through testing. So all these things are, I think, the biggest challenge is putting together integrated vehicle. Individual components is going to be great. Is making sure we test and making sure that the integrated system works well together. And that is one of the biggest things. And then, of course, integration, interfacing with other elements. So docking with a human landing system. That's going to be a challenge. Not that we haven't docked before, but it's a very different size vehicle.
Sure.
And we're doing it in lunar orbit. Something we haven't done before. So to me, a very different environment, trying to do a function that you've done already in low Earth orbit, translating that, and also with a different vehicle. And that integration with a different company, with a different culture, with a different operational model, are all things that are challenges. So integration on one side, and then of course the technical aspect of what we do on a daily basis.
On the podcast, we have lots of different experts and people from all walks of life that come on, including students. And we're always talking about why space is important and trying to get the next generation inspired and interested in space. Why would you say that space exploration, getting humans to the moon and getting humans to Mars, is important for humanity?
Well, to me, we are explorers by nature in our DNA. And what more exciting mission that you can be part of? I tell the students all the time, unique.
Yeah.
We work in a very unique environment. We have challenges that are daunting. And, just sending people to breathe and walk on the surface requires infrastructure that is amazingly complex and difficult. And I don't know, for me personally, trying to tackle a complex thing is what's in my DNA, and I think that's what's in humanity's DNA. We are, I think, conditioned, or as part of our what's built into our mindset and our drive is to explore, but also to solve complex things and really be challenged by that. And I look at space as the frontier of the future. And that frontier of the future is what makes it exciting, because you don't know what's going to come out of it, number one. And you don't know what you need. You need oxygen, you need fuel, you need the basics. But what else do you need to survive and to live? And how do you live and survive for months or years? And that is a very different dynamic than me building a spaceship. That's a very different area. That's a very exciting unknown area that requires a lot of great brain power, I would say, to get there, and passion. And I think that this space program, to me, is the best area to work in the world.
I absolutely agree with you. When we look at humanity's milestones and historical moments that have defined us, getting humans to the moon was one of those, and I think that's kind of one of our peaks as humans. And so we look back at the space industry, and I tell students that I talk to, space is all around you. You may just not know it yet. Your camera phone, your iPhone, your GPS, your water filtration system, like all of those things come from the space industry, and that's why it's important that we continue to be explorers. We go back to the moon, we go to the Mars, so that we can continue to see that innovation. Anything else that you're excited about in the future? Obviously getting humans to the moon, getting to Mars, but what else are you excited about?
What really excites me is it brings people together. When you talk about excitement of students, it's not just American students.
Right.
It's students I see globally, around the world that I talk to, that really are inspired by seeing that there's a future that is achievable and that's being done today.
Yeah.
And having those steps versus a cartoon or something else where you see tangible things that are taking those, I would say, baby steps that allows us to have that grander vision.
Yeah.
But you see that grand vision, you see the pieces coming together. I think that's awesome, and that gives students around the world, I would say, opportunity. And I think it also brings people together. Space is a common collaborative and what's the word I'm thinking about? A stitching of whatever society you are. People understand, looking out in the moon, looking at other planets, right, and seeing that, and I think it brings people together for a common unity that allows us to move forward together as humanity. And I think that's really what I think is great, is I'm establishing or helping establish that foundation that provides that infrastructure that people can accomplish the vision that we collectively believe in and want to see happen in the future.
I love that answer. And on the topic of students, we are at your alma mater, so we're on the University of Washington campus. What advice would you give to students and to young people that are interested in space and they're passionate about it? What advice would you give them to get into a position like you and work at NASA and be a program director?
Well, nobody should aspire to be a program director. I'm not sure that's
fair,
a great job.
Fair,
but,
okay.
I didn't aspire to that. But I think, the key is, I tell students all the time, find something that you're passionate about doing in the space industry. So whether it's designing a rover, or, hey, I want to build life support systems, or I'm really interested in testing, find things that fit your personality. That's very important because you're going to be doing that. You're going to have to get up. You're going to be working those long hours.
Yeah.
You're going to be working weekends. You want a job that you're passionate about, that fits your capabilities, that you are interested in. And I think that's really important. And that's why the space industry is awesome, because there's so many different jobs. From my perspective, when I was doing guidance, navigation, control, and doing design simulations, but there's people that I know that did testing, that, like I said, builds toilets. There's just a whole spectrum of job, and we have communicators at NASA. So to me, it's open to everybody, as long as you have an interest in the space program and we have a common goal, common vision, but there's lots of different pieces that are needed. And so I think about what's your skill set, what you're passionate about, and what you want to do in your daily work. Do you like sitting behind a desk, or do you want to be in the lab?
Yeah.
That's really important. I think that's a real big distinguisher.
Yeah, absolutely. Well, I appreciate your time and speaking with me. Thank you so much.
Thank you.
It's been a pleasure.
Yeah.
You heard it here first. Find your passion.